Hi, my name is Steve Sheldon with the Home Inspection Training Institute, and today we're going to take a look at an electrical panel, and we're going to discuss some of the features of the electrical panel, some of the things that you as a home inspector will need to look for when evaluating an electrical service. So the first thing that we're doing is in this particular house, you'll notice that we have a panel right here. This panel is located in kind of a difficult spot, actually, and that's really where we're going to start off with this inspection, is that the NEC, now I know we're not doing a code inspection, but it is important that an electrician be able to have adequate service area on this unit. So you'll notice here that we don't have a lot of room to the left, plenty of room on the right, but the code actually recommends that we have 30 inches on either side of the panel and 36 inches in front. So we meet the 36 inches in front, but we really don't on a side-to-side basis. So I'm certainly going to make a note of that in my inspection report. The other thing that I want to note before I take this panel off is that this is the legend. This tells me what all these breakers are to. Now, as a home inspector, I'm not required to test these breakers to see that they match up with this legend. I don't want to do that. I just note the fact that this legend has identified what all of these breakers are for. With that being said, the next thing I'll do is I will take this panel off. Now, one of the things I want you to be cautious about when taking a panel off is it really makes sense to have some shatterproof type glasses, glasses that allow you to, if for some reason there should be some sort of charge from the panel, you're not going to get blinded, or you're not going to lose an eye. You also want to make sure that you approach the panel with the back of your hand. That way, if the panel is charged, your hand will release as opposed to grabbing it. Your hand will tend to tighten here, and you won't come off the panel. So with that being said, we're going to remove the panel. In removing the panel, one of the things I want to make a special note of is to note that all of these breakers, except for this breaker up here in the upper right hand corner, are in the on position. So I want to just make sure that when I take this panel cover off and put it back on at the end of my inspection, that the panel's in the same condition that I found it in, and those breakers that are on are still on, and those that are off are off. This actually is labeled range, and I happen to know on this house that they don't have an electric range anymore. They have a gas range. So that is why they've shut that breaker down. So I'm going to take the panel off, and in so doing, I'm going to note that these screws are actually blunt screws, which is a good thing. If I had pointed screws, that would be a concern, because I could theoretically pinch one of those wires inside the panel. And you can see that the clearances do make a difference here, because this panel is a little more difficult to take off, the fact that I don't have any room over here on the left side to do it. You'll notice that I'm actually holding this panel from the bottom, and that's so it doesn't slide down when it does come off. I want to make sure that I carefully take the panel off and bring it out towards me. And as I do that, the panel actually acts as a shield if there were something to go amiss when I'm taking that off. So here we have the panel off, and I want to point out a couple of things to you as we go down, starting at the top and come down. Okay, as we look at the panel here, the first thing I want you to note is where the service entrance cables come into this panel. We have two service entrance cables, 120 volts, 120 volts. Together, they make up 240 volts. And 240 volts are used for some of our larger appliances, like an air conditioning unit, a range, those kinds of things. Whereas 120 volts, which is really just one leg of this service, is adequate for things like most outlets, lamps, those kinds of things. So as we look down here, you can see we've got the two hots, 120 and 120. Together they make 240. You'll notice as we move down, this is the main service breaker. This is 150 amps. And everything down below this is our branch circuit wiring. So all of these are the breakers for our various components within the home. Notice that we have another wire here, which you can see as it comes down. A little hard to follow it, but it's coming over and it's actually tied in up there, and that is our neutral wire. Okay, that's our neutral wire, and our neutral wire is what takes the current back to the source. Okay, and this is our grounding bus bar here, as well as our neutral bus bar. And okay, it's hard to kind of see it, but way up here in the upper left-hand corner, there is a ground wire that runs from that bus bar all the way out to the ground rod, which is 8 feet in the ground behind the home. And that ground rod is there to protect the electrical system, really, against freak things like a lightning strike or power surge, something along those lines, a voltage crossover that could occur. And if that were to happen, that electrical current would go to ground and spare the electrical system any significant type damage. You'll also notice that that bus bar there, it actually needs to be bonded to the panel itself. And again, you can't really see it up there, but there is a screw, and it normally is a green color screw. In this case, it's not, but you can actually, I can see it from here, and that actually bonds that bus bar to the electrical panel, and that keeps everything grounded, and that's essential in a main panel. And this is a main panel because this is where our main disconnect is located. There's only one main panel, and that is where the main disconnect is. Anything downstream of that becomes a sub panel or an auxiliary panel. So we've identified these hot wires, which are the ungrounded conductors. And then we have all these neutral wires that you'll see over there. And those neutral wires, are considered grounded conductors. Again, that bus bar ties into the panel, which everything, this whole, the guts of this panel, everything is tied back to the ground, which is outside. So sometimes that screw up there will be green, sometimes it's not, but you want to make sure that if you can, that screw is intact, it's there. If it's missing, that would be correct for a sub panel, but would not be correct for a main panel. In a sub panel, the grounding bar would be isolated from the other neutral bus bar, and only the grounding bus bar would be bonded to the panel in that case. The grounds and the neutrals in that situation would be isolated from each other because we don't want current to be able to flow in a parallel path. And a parallel path is where if you had the grounds and neutrals together in a sub panel, then the current could take both paths back to the source, and that's what we don't want. We don't want current traveling on ground wires. We want to keep the current traveling on the neutral wires. If they travel on both, we call that a parallel path, and that is what we're trying to avoid. That's dangerous when we allow electricity to flow anywhere outside of its intended path, which is the neutral wire in this case. You'll notice as we look at this bus bar here, we have more than 2 wires under the same screw. And we have one there, a couple up here. And the problem with that is we do not want more than 1 wire under the same screw. We want those wires to be under separate screws because, again, even though those are neutral wires carrying current back to the source, they still could potentially arc, and if they did arc, that would be a problem for us. So we do want to make sure those are under separate screws. And then the last thing I'll show you here is we have a neutral wire actually being used as a hot. And when we see a neutral wire being used as a hot, that wire ought to be labeled. So that either ought to be encircled with electrical tape or marked with a black magic marker, preferably circled with electrical tape. So here I want you to note that we have several different breakers here. These are double pole breakers, 30 amp, 30 amp, 30 amp. Then you'll notice we have a test breaker. That's actually for a GFCI that protects the jetted tub that's in the master bathroom. Now sometimes these GFCIs will be in the wall with a push button. Sometimes they will be hardwired directly to the panel, as you see in this case here. Now our job as a home inspector at this point would be to test that, and you can see as I push on it, it is not tripping, which it should trip, which is something I would want to write up in my report, because a GFCI protects you from a ground fault, which around water could be deadly. So that's a very important thing that we want to call out in the report. As you look down this panel here, you'll notice that we actually have over here, right here, we actually have a double tap. That's 2 wires under the same screw, and that's something that we want to call out in our report, because that is a potential arcing situation which could cause a fire. So that's something we want to isolate those two wires from each other. And the best way to do that is through this, what we call a tandem breaker. These breakers right here are tandem breakers. That's to prevent that double tap situation. So on each of these you'll notice there's an individual wire, and we were able to do that by putting a tandem breaker in there that fits on one single bus bar and allows us to screw 2 hot wires, each under its own screw. One of the other benefits of tandem breakers is that in a panel, for example, like this, we've essentially run out of room in the panel to add additional circuits. And so the option would be to run a sub panel. So in lieu of that, we can fit more breakers into the panel by using tandem breakers. And that's another advantage to using tandem breakers. Something else in the top left-hand corner of the panel, I just wanted you to see where that white jacket is coming through of wires, and you'll notice that there is no bushing on that, and we really should have a bushing there to just make sure those wires do not loosen. Finally, I'd like you to note about this panel is that all of the breakers are consistent in this panel. These are Cutler hammer breakers, and this happens to be a Cutler hammer panel. If we saw GE breakers or square D breakers or something in this panel, a mismatch, you would want to call that out. There are some breakers that are compatible to other panels, but you're not expected to know what that is as a home inspector. So the best thing for you is, if you see incompatible breakers, simply call it out and let an electrical contractor determine whether those are acceptable or not. Well, we're outside now at the back of that house where I told you the ground rod was placed, and this right here is the ground rod. And you'll notice that that wire coming from that panel that we talked about, from the grounding in the panel, this is a number 6 gauge wire for 150 amp service. If the service had been 200 amps, this would be a number 4 gauge wire, but it is a number 6 gauge wire. And you'll notice that it's clamped onto this ground rod, and it's not very secure. And so that's something I would definitely want to write up. That clamp needs to be secured to the ground rod. And this ground rod really should be all the way in the ground. It's an 8-foot ground rod, And you can see here we still have a good 8 to 12 inches sticking up out of the ground. So I would probably recommend that this also be further driven into the ground the full 8 feet, and also secured to the rod. In a lateral service or underground service, this box that you will typically see maybe every other lot on a street, this is the transformer. This is essentially what transforms the power from high voltage, which runs under the ground, to a voltage that you can use in your home. So it said, again, this is with lateral service. This is the transformer, and the power that we talked about earlier is always trying to make its way back to the source. And the source in this case is a transformer, which is this box here that sits on somebody's front yard. And here is an example of overhead service. And those two cylindrical things mounted on the pole there, those are your transformers, and that's what transforms the power down to something that you can use in your household.